Hi everyone, welcome to this week's episode of Sealed for Good. I'm your host Yandi, and today we'll be discussing thicknesses of membranes and how different thicknesses affect performance and things to look out for. Hope you enjoy. Film thickness. So there's two film thicknesses that we refer to. We have the wet film thickness, and then of course we have the dry film thickness, which is the thickness of the membrane once it's gone through the curing process. With water-based products like the one I have in front of you, 38FC, it will evaporate the water content, and then from the wet film thickness of around 1.5 mil, that will then shrink down to about 1 millimeter. So we need to be familiar with obviously the wet film gauge and also how to check and ensure that we're applying it at the right wet film thickness to achieve the correct dry film thickness. And as we've covered many times before, the importance of the dry film thickness comes down to product testing and conformance. So if you pick up one of our products and it says on the TDS must be applied at this thickness to achieve a dry film thickness of 1 millimeter, and then you reference our test report, you will find identical film thicknesses. If anything, the test report may sometimes be tested at a lower film build to ensure that there's a buffer there to ensure that the product will perform as the requirements under the NCC. If you come across a product that claims it can be applied at 0.5 mil, it's important to always confirm that with the test report, and it should be the same thickness. Otherwise, it means that there's no evidence that that product actually will perform under the requirements under the NCC, and that product will likely need a performance solution because it cannot prove with empirical evidence that it can do the job. So what do we have in front of us? We have membranes that we've applied over some plastic sheet. I've peeled it up, and straight away you can start to see the challenges when it comes to performance if you don't apply it right. So over here, I've peeled it off the sheet. All of them, all the specimens were the same size, but because this one's been applied at such a thin coat, it's almost translucent. But if you put it up against a substrate, it does look like a coated, fully coated system. But when you actually take it off, you can see it's very, very thin, paper thin. So when I was pulling it off the sheet, because it's thin, it's weak. And because it's weak, it tears. And this is precisely the risk of when you under apply a membrane, right? So if you're not getting it to the right thickness, it's not going to be strong enough. It's not going to reach full adhesion. It's not going to have the right water vapor transmission properties. It's not going to have the right elongation properties. It's not going to have the right tensile strength properties. So pretty much across the board, it will not perform as per the assurances that we provide in the technical data sheet. So this is probably one of the worst case scenarios, is under applying the membrane. It will not be able to handle bleach. It will not be able to handle detergent. And even if you put this in water immersion, it's just going to deteriorate much quicker than a membrane that's been applied at the correct film thickness. So in the middle here, same sort of thing, same sort of specimen. You can clearly see that this is quite a thick coat of membrane, and there's a few disadvantages to that. So it's hard to kind of simulate what would happen on site. We tried our best, but if you have a close look, there's a bunch of crazing and cracks, right? So these did start off just as surface cracks, but when I've peeled it off, it's transferred through the whole membrane. But generally what you'd see on site is splitting on the surface. That becomes a weak point, and that's quite evident when I peeled it up. It fractured all the way through. So too thick, what happens is the membrane will dry quite well on the surface, then underneath will continue to dry, it'll shrink, puts tension on that surface, and it can then slightly craze. There's other things as well that happen, but generally speaking, that's what the risk is. The other thing, you can see here that this is quite still almost in its plastic form. It just doesn't cure the same. So what's underneath and inside is very, very soft compared to the surface. All right, so you might think, oh, okay, that's pretty good, but underneath that thick layer, it's still not completely cured. And again, you're not going to get the same type of tensile strength and things like that. If for whatever reason you want to increase durability and you want to apply a thicker layer overall, the way you should do it is with consistent additional coats, not heavy coats, because that's what you run the risk of. And then over here, a thickness that's been applied correctly. So again, I've peeled this off. It was pretty easy to peel off. It was consistent. When you look at the back, it came off clean. There weren't tacky and uncured sections that bind to the plastic that didn't let me release it. Like there are some, bits that sort of stretched and things like that, but it's just consistent. right? And as expected. And that's where the thickness really matters. What we're gonna do, we're gonna cut these to equal sizes, and then we're gonna show you how else performance is affected. I've cut them to pretty much similar sort of size, width, length, that sort of thing. And what we'll do is just be able to now see where the different lays. So if I grab each end and then we just start to slowly stretch it, straight away, it just tears apart quite easily. You know, you guys can't feel what I'm feeling, but there's really, obviously there's nothing there because there's literally nothing there. All right, so if we move over to the thicker samples, so the ones that were too thick, so I've got 2 of those just so you can see where you have something that's cracked or crazed, how that will affect performance, which is pretty obvious as well. It's a failure point, a weak point. And yeah, it's stretching because there's a fair bit of body to the membrane itself. So you can see this thin section, that's even stronger than the one I just did before. But again, because it's already fractured, it's just gonna fall apart. The other thing I wanted to demonstrate when you go arguably too thick is the inside of the product. It's quite soft, it's spongy. It's not going to cure the same way that a product that's been applied evenly over 2 coats. You're going to end up with soft sections. And again, because it hasn't fully cured, it hasn't reached its full strength. So again, it kind of just breaks down, you know, good elasticity, no doubt. Plenty of product there that can sort of, you know, redistribute as you're stretching it. There it goes, there it goes, there it goes. But because it hasn't fully cured, because it's still weak, then that's what you're going to end up with, this kind of chewing gum type of situation. Eventually this would cure. There's, you know, sometimes you get lucky and it won't craze, and you end up with a very solid film, but ultimately it's just, there's a better approach, which is this one here. 1 good coat applied at the correct thickness. And then if we do the same thing, stretch, 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 and I can feel now that it wants to sort of pull back. I can feel that that tensile strength has been developed. Still going, still going. You can see I'm actually now slightly struggling, still going, and then eventually it will snap at some point, but it's worlds apart, right? It's just a better membrane. It's almost like an elastic band, right? So big difference when it comes to film thickness, and something that we do need to be aware of. So how do we achieve our correct thickness? The most obvious way as an installer, of course, is using your wet film gauge. So these are readily available from all our suppliers. If they don't have any, let them talk to the guys, we'll get some out to them. No dramas whatsoever, it's essential. There's also visual cues. So if I look at this that's been applied on this wall, by looking at it, I can be pretty confident that the film thickness close, if not precise, and that 2 coats have been applied, right? So the gauge confirms, and then you use a visual cue. The other thing that you can do is obviously you measure what you're using. So 15 litre Paddler 38FC, the product that's been applied here, that would do 10 square meters. So you measure out the area, and you should be able to govern that if it's a 10 square meter room, then that whole paddle needs to be applied. And then you can kind of then make sure that it's spread out evenly, and you should be confident also that you'll achieve the correct film thickness. So there's lots of ways to confirm that you're on the right path, but the only way to verify is with your wet film gauge, right? So again, looking at it, we've got those big ridges, and you have the 2 coats applied in different directions. So I can see that there's 1 coat underneath, and then the 2nd coat being applied over. And again, it looks pretty good. There's a few episodes that we have on the channel, check them out. They go into a lot more detail when it comes to the way we test membranes and how to read the textures to make sure that you're getting the right or achieving the right thicknesses. So here we have a pre-primed board, and it's as simple as applying the product and then just having a look at that texture. So again, if we're sort of using the texture behind me as a bit of a visual cue and understanding that that's probably right, then we're trying to achieve that same thing. So there are going to be some nuances. So the type of roller you're using, the amount of pressure you're applying, you know, your style might change the texture, and that's why this is still a critical component of confirming the wet film thickness. So 750 microns, here we go. That's the minimum for the first coat. In between the ridges, so we actually go for that lowest point, okay? You don't want to go across this way because you're just going to touch those high points, which then will give you a false reading. So you want to go through here, press it in, push it out, and then right here, it's completely covered the 850. So it's in between 850 and 900. So I have more than enough. And I was confident before I even pressed the gauge in there because I'm really familiar with my style of applying the product and the texture I need to achieve. So that's not to say that if you go from this end here, all right, so even though this has already been pressed in and you can see the wet marks, you can use it again because you can also count the dashes. So if we go from the end, the two ends, 1, 2, 3 in, so we are at 1, 2, 3, 750. So I've met the minimum at the thinnest point, and we're over here where you have the majority of the membrane. If I try that again, you'll end up with about the same 800. So from this point back, very consistent. Over here thins out a bit, but I'm still at the minimum. Overall, beautiful, okay? So again, you look at that, you look at this, all of a sudden you can be pretty sure that you're achieving what you need to. So what happens when it dries? So generally when it dries, then we move into a whole different space, which some professional applicators will conduct dry film testing as well, using something like this. Generally, inspection professionals will have maybe a more sophisticated piece of equipment, and generally speaking, they will have a form that will tell you when that equipment was calibrated, so they can be pretty confident that it's all operating as needed. From there, before the inspection starts, they'll use a calibrating pad. So this one's set at 2,472 microns, and you should do several tests. So that's 2.5, 2.47, go again, 2.45, one more time, 2.44. So what I should have been doing is taking down those readings and then dividing that by 4 to get the average. But just by sort of looking at it roughly, you'd be very close to that 2.472 kind of mark if we were to do that. So then you kind of repeat the process up on the test area. So inspection professionals are always operating to a ASTM or a standard test method, and that will guide them as far as what they need to do, how many readings they need to take, and all that sort of stuff. So if we just get our texture out, 1.16, okay, 1.0 plus 1.0 plus 1.3 plus 1.16 equals, we divided that by the 4 specimens, which gives us our reading of a healthy 1.1. Just goes to show, by understanding that process of the wet film thickness, checking those visual cues, using enough product, calculating the consumption of the product, all goes back to the testing, all ticks that box for compliance from National Construction Code requirements as far as the testing and the thickness, that then gets relayed back into the technical data sheet that then we calculate into wet film so you can apply it correctly, and it comes to this result on site. So that's it when it comes to thicknesses with membranes. If you have any questions, please reach out, and until next time, happy waterproofing.